Welcome to Timeless with Vivek Nittoor. Our guest today is Professor S.P. Sukhatme. Professor S.P. Sukhatme is Professor Emeritus in the Department of Mechanical Engineering at IIT Bombay and has been a faculty member there since 1965. Professor Sukhatme worked as Deputy Director from December 1983 to December 1985 and as the Director of IIT Bombay from January 1995 to January 2000. He then served as the chairman of the Atomic Energy Regulatory Board for 5 years, up to January 2005. Professor Sukhatme earned a bachelor's degree in mechanical engineering from Banaras Hindu University in 1958 and subsequently earned Master of Science, Mechanical Engineer, and Doctor of Science degrees from Massachusetts Institute of Technology in 1960, 1961, and 1964, respectively, all in mechanical engineering. Welcome, sir. How have you been? Sir, I had heard a lot about you from our mechanical engineering friends when I was a student at IIT Bombay, even though I did not directly come into contact with you during those years.
Well, thank you, Vivek. Great to be on this program with you, in which you are interviewing many people connected with IIT as faculty members, alumni, etc., etc. I think you're going to have some very good, a very good collection at the end, which many people will want to listen to. So that's great. It's a wonderful activity in which you have started. And to those who are going to hear this interview, you can call it a session with Vivek. Uh, Many of you will be alumni, many of you will be other people not connected with IIT, but all those who hear this discussion we are having, great to reach out to. And, whoever, great to reach out to all those who hear what I have to say. Let me also thank Professor Uday Gaitonde at the beginning. Thank you, Vivek. But the other person who's been sitting, who's done all the planning for this for me, and I'm using his laptop actually also, is Professor Uday Gaitonde. And many of you would know him because he's also IIT Bombay alumnus, mechanical engineering, and was with the, has just retired. He's just around 70 now. So he's been with the institute, and many would have been associated in some way with it, particularly if you are alumni of mechanical engineering. So he's helped me a lot, and that's great. All this is possible because he's helped me. Uh, Before, however, we start the discussion proper, I thought I should mention that this is a strange, difficult time in which to have this interview. We're having a pandemic, COVID-19, all over India, all over the world. It's affected us in ways we haven't even have imagined a few months ago. It would be locked up like this, sitting in a room and really not being able to do things like just going out wherever we want. It's very unfortunate. We have to live through it, and hopefully all of us will manage to live through it well. We have to be calm and patient and obey the rules. That's what it is during this period. We've got other problems as well with this pandemic. We're going to have economic issues coming up now in a bigger way. Few more problems associated with poverty, unemployment. They'll need to be tackled, no question about it. And in addition, we have some political issues on our border with our neighbors. That's also worrisome, because it almost seems as if some of them are waiting to see when you are in distress, and they would like to sort of put in their make their cause more evident or trouble us more at this time. It almost seems like that. Anyway, whatever it is, as citizens, we should do what the nation expects us to do without thinking of our political affiliations. Now, I don't have political affiliations. I'm not saying that I'm from one of the other party. But what I'm trying to say is it's a time for national unity when we face so many things at the same time. And I think at my age, to request you all who hear this to, to use, to be, to ensure national unity. and to work with whatever is being done by our leaders is very important. Now, today, of course, this is a wide-ranging discussion that I'm going to have with Vivek. But I don't want to focus on some parts which are before I joined IIT Bombay and the parts in which I was after I left or retired from IIT Bombay. For instance, I'll not make too much reference to my school, my high school, which I was in Delhi. I'll not make too much reference to my days in PHU. I will refer to it when I talk of the curriculum later, but I don't think I'll talk in detail about my days in the hostel, my friendships there, and so on. I'll not talk too much also about my uh, association with atomic energy because, that will make things the discussion far too long. I think that's not called. So not intentionally not talk about these areas in which I've been working or have been associated.
Sir, it is great to have this discussion with you. What was your primary motivation for choosing an academic career after your doctorate? What was the main reason for choosing to return to India?
I think the decision was not taken in BHU. The beginnings of such a decision, or the thought that I would enter a career which involved teaching and research, sort of was in my mind by the time I left BHU. It got strengthened after I went to MIT, where also you had to occasionally make presentations while doing your PhD and so on. That's the way I took it.
Sir, could you please speak about the persons who influenced your life in the early years, spanning St. Columbia School, BHU, and MIT? Your father was an eminent statistician. In what way did he influence you?
Yeah. Well, that's a big question. You can say a lot on it. So let me be a little brief. Uh, the academic career was something which came almost naturally to me as something I wanted to do. It didn't happen suddenly, but it certainly came to me naturally. Over the years, as I grew older, it came naturally. The beginning probably was when I was very young. At home, my father was a statistician, as you know, a well known statistician in India, pioneering statistician. Started the random sampling methods in India for estimating agricultural production of all our key crops, wheat, rice, etc. And this was in the 40s when India was one of the few nations in the world adopting these techniques. Okay, so we were with the rest of the world in science at that time in this respect. So he did this because he came back with a PhD and a DSc from London University and knew what he wanted to do. And the academic atmosphere was there in the house. Research was very much in the house. You see, he was a very busy person. He worked very hard. There were rare occasions when he spent time with us. But in the house, there was always that atmosphere. He would go in the morning and return at night every day from the office. A lot of touring to do to see how the projects which he had ongoing for estimating crop production with sampling techniques were working. And all his statistician friends regularly came to Delhi for group meetings. 4 or 5 of them who were like uncles to me in a sense. And they came and stayed with us, 4 of them. They were statisticians in their respective presidencies. The Bombay presidency had one statistician, agricultural statistician. The Madras presidency had one. One was in Uttar Pradesh called the United Provinces, and so on. So all the discussion at home also would be on statistics and the using of the techniques, which are in different ways being implemented in different states. And that's why the discussion when they came for meetings, how things were going, how to change things so that better results are obtained in the next season and so forth. So in a way, academics was in the air when my father was around. And the other thing was that he was also wanted to teach. So when he was there itself, since there was a shortage of statisticians who could teach agricultural statistics, there were none actually. He started a diploma course, a postgraduate diploma course in the ICAR, the Indian Council of Agricultural Research, where he worked as part of the Ministry of Agriculture. Started a course in which they used to take, I think, about a dozen or 20 students every year and teach them agricultural statistics, the principles, the elementary ideas, so that they could go out and apply these techniques of sampling techniques and other techniques also. And so he was in effect a professor, not called a professor at that time. And when he came back after his retirement, of course, he was a professor in Pune. Those were his last 25 years in Pune after retirement. So academics was very much in the air. And I'll tell you in a light sense, sense that I always thought, because of the number of times I've heard the word sampling and agriculture in the house, that I thought that sampling was only done in agriculture. The two words I thought went hand in hand. It took me some years when I grew older before I came to know that sampling came from statistics. It was being applied, in his case, to agriculture. Some techniques were being applied to agriculture. You understand how much it was ingrained in my head. He never influenced me in the sense he said, none of us, I mean, for that matter, his children. He never said, do this, do that, take this subject. My sister became a doctor. I became an engineer. My younger brother went for physics first, and then the youngest went back to being a doctor in the US. My father never said, oh, why doesn't one of you be a statistician? No, none of that. I still remember his once saying, he says, whatever you choose, remember you have to be at the best, among the best. Remember that. That was his advice. He says, there's no such thing as saying, it's okay, I do it, I'm okay. None of that. Always try to do the best so that you are the best. That's the way I look upon things. And that was also a very good influence. He didn't want us to do something or take a specific subject. And he was a very busy person, let me tell you. I hardly used to meet him. Now that's surprising, in the same house. But his influence was this indirect influence. You grow up in an atmosphere in which you start seeing something which you want to do. And then you're given the freedom to do what you want. So he was a great influence on me. At home also, there was another major influence. My younger uncle was with us. He was doing his MA when I was 7 or 8 years old, and he was doing his MA in mathematics in Delhi University. And he used to be at home doing his, or you can call it homework if you like. He used to solving problems in mathematics involving columns and sometimes data with which you have to calculate means, calculate averages, sometimes distribute the data, determine distribution. That was the statistics part. But he used to do various things in algebra, factorials, combinatorial algebra, and so on, and even matrices. And so in all of them, there were calculations to be done, problems which he had to do. And I used to stand at his table. No talking, mind you. I used to just listen, see what he was doing for hours on end. It fascinated me very well. And my mother would often say, you're standing there, you're disturbing your uncle, your kaka. But he's always said, no, 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 no. He doesn't do a thing. He's just standing there and watching. And then numbers sort of grow into you if you see them all the time. And I remember as I grew a little older, a year later, we had a calculating machine, a mechanical calculating machine. You rotated it and to multiply so many times, and to divide you went the other way and things like that. And facet calculating machine, I remember. And he used to use it all the time because many of the problems required long calculations. And then, as I grew older, he sort of thought he could give me some of that responsibility. So he used to tell me, do this. So first as a test, he would give me some things which he had done to see that I could do it right. And then when I could do it right, he would often leave me and say, can you do this for me? And I was so happy to do them for me. He told me but once, no mistakes, no mistakes. No, not even one mistake in 100 calculations. That was his quality control standard. And I kept it, no questions. He said, one mistake will not do. The machine is doing the work for you. You're just feeding in numbers here. No mistakes allowed, period. So you built in within you a certain, what I call, excellence. You say, I'm not satisfied with 9 out of 10. I'm satisfied only with 10 out of 10. So, of course, he was our friend in so many respects. He did many odd jobs in the house, carpentry, doing certain things, repairing certain things. And because of that, I also developed some interest in these things. which are trivial in a sense, but still, it's good that you got involved with them. So he was a great uncle for us, and both my sister and I, my sister was just an year and a half older, used to adore him, really, in whatever he said to us. Took us out always, and whenever he went shopping, vegetables, this, that, anything. If he said we wanted to come, he would never say no. That was his attitude. You got to learn by coming with me, he said. And he took us with all the care that was needed. So he was the second major influence. He went on to do a PhD in statistics from Berkeley, by the way, later on. Much later, because he was 14 years younger than my father. But he did a PhD in Berkeley and then, of course, carried on a career in statistics. Passed away young. And of course, I would say till I joined IIT, the third major influence on me was my thesis supervisor at MIT, Professor Warren Rosenau. He's a world famous figure, by the way, by the time he was teaching, been supervising me, well known for his work in heat transfer. If you study heat transfer, you will still see Rosenau's correlation for nucleate boiling, which he first suggested in the 50s, late 50s. That's the kind of impact he made on the subject. And he was a great influence in the sense, again, like my father, it's not that I saw him every day, not at all. When he was my supervisor, I remember I met him. After I passed the qualifying, I wanted to have him as the thesis supervisor. And, he was already so well known, busy. I was, little tentative. How do I go and say it to him? Before that, I just crossed him here and there, in the corridor. And whenever he crossed, he would smile, say hi, the usual American way. And he had a pipe which he used to smoke, and jolly person. So I was a little hesitant. I said, do I just walk in and say something? And then somebody who was another professor there, a younger professor, with whom I worked during the summer and one semester on a research project. He said, yeah, just walk in. Just go to his secretary, say you want to meet him. He will. Don't you worry, he said. So I did that, and then I went to him and I said, sir, I've passed the qualifying exam for the PhD, which used to be a tough exam at MIT, mechanical engineering. Barely 1 out of 3 used to get through the first time. I said, I just passed it, and I'm, in heat transfer. I'm keen on doing it. I've done a research project as a research assistant with so and so in heat transfer, and he won't be here. That professor was leaving, and I've come to you. I mean, he said, okay, good, great, that kind of thing. Then he spent some time with me getting my background. He actually knew my background because he was also the graduate registration officer for the department. So I used to meet him at that time while you register in each semester. So he said, fine. He said, what I'm going to do is the following. I have two broad problems in mind. They're new. No, there's no continuation that I've had a PhD student and somebody is continuing from where he leaves off. No, not like that. These are two new problems which are in my mind. I think they're worth doing. I think we can get sponsorship for them. That's important, to get money, because I would have been a research assistant on a project with him. We can get money, he said. That's not the issue. That's not going to be your problem. But you need to first write a research proposal. I'll give you some initial references. You read them. You come back and you tell me after some time which of the two you've picked, and they're both going to involve some experimentation, he said. And in the research project which you worked on here, you've done a fair amount of experimentation. So you should be able to manage that part. And let me know. Then get down to the business of writing a research proposal, he said. And we'll send it off to the agencies, and we'll get the money. He was so confident. And I like that confidence, of course, he was well known. But that doesn't mean every project you ask for money, you'll get the money, kind of thing. But he just said, go right ahead, he said. And he said, whenever you are ready, see me. There's no such thing, see me next week or see me after 2 days. Many professors at MIT were like that. They would want every other day to know somebody is going to work with them, what they were doing, kind of thing. He wasn't like that at all. So I really worked hard for about a week or 2 weeks. consulted some of my friends, got references from the library, and gradually worked up to a point that I picked one of the topics. It was going to be experimental in nature. It's going to be a very new topic. In the sense, it would have been, even for the America at that time, it was a fancy topic. Let me tell you, fancy in the sense it involved using equipment which people don't use. It involved using fluids which people don't work with, and so on. As it turned out later. And it was on, just to give you an idea, it was on the condensation of liquid metal vapors. Liquid metal vapor, the best liquid metal we know of is mercury. And there are others like sodium, potassium, mixtures of sodium, potassium, etc. And these were being considered as heat transfer fluids at that time. People wanted to know whether as heat transfer fluids they could be used for certain specific problems which the Atomic Energy Commission in the US Atomic Energy Commission was interested in. So he said, okay, if you study film condensation, you'll have to vaporize one of these liquids, you'll have to condense it, you'll have to make measurements. And the preliminary data from other publications showed that while there was data, it was very, very scattered. And a variety of reasons had been given for it by the authors of the few papers that had been written. So I said, we've got to look at this, look at more deeply, and come up with what we think is good data for a particular fluid which you have to pick. That was the problem. And so I said, I spent time, as I said, I picked that, spent time then in deciding what fluid I would pick, what would be the nature of the setup. You had to boil the fluid, you had to condense it. It wasn't water being boiled in a steam boiler and condensed on a tube, you understand? It would be a liquid metal, and the temperatures would be higher, and so on. And I spent quite a bit of time. It took me 3-4 months to sort of come to a situation where I was meeting him in between, but he would listen carefully to whatever I had done, but never said, don't do this or don't do that. He said, good, great, go right ahead. That kind of thing. Spend just 15-20 minutes with me. At the end of 3 months, I had a proposal, which we sent to the Atomic Energy Commission, the US Atomic Energy Commission. And uh, it takes its own time. Proposals have to, that's the government also there, goes to reviewers, this, that. And it took about 3-4 months before the money came for it. But in that time, here I was sitting on edge, wondering what would happen. He had seen the proposal, of course, but it made a few small corrections to what I had written, nothing much. The only part was when it came to the budget, which he told me he would write. He asked me what instrumentation we would need, and then he got me to estimate the costs of that instrumentation. Then the other part about staff, etc., I said, I'll write that. I know how to write these things. You'll probably underestimate what you need, things like that. So we wrote a proposal, went there, and it was taking time. And I met him once, said, I'm worried, no reply from them. He said, come on, he said, Suhas, don't worry. It'll take its time. We'll get the money. You just carry on as if the money is come, okay? That's a kind of reassurance which you get from your guide. You say, okay, you go right ahead full steam. You design the setup, you start making drawings for it. Everything you do when you're a student, you don't have anybody to make drawings for you. Detailed drawings of the setup. You have to consult a lot of people because it would be a vacuum-proof system. I decided to use mercury, and mercury is a toxic substance. So, what precautions do you take? I used to have a mask, by the way, like I'm wearing just now all over. We're wearing, but a much better mask in case there was an accident, in case mercury vapor came out. Well, you had to always have that mask on your face so that no damage. You could take the other steps later in case there was a leak. Things like that. Now, just to describe to you the nature of the setup would be too long, but I can tell you that I had my first experience with nuclear energy then because I decided to use a radioactive method for measuring the thickness of the film that was condensing. And I used gamma ray attenuation, which was quite new in the US then. I picked a source, it was cobalt 57, quite a strong source. So I had to learn shielding for it, what thickness of lead would be needed around it, what kind of opening you could allow so that nothing else came in its path, safety measures before buying the source and so forth. I mean, the room in which I worked had a sign outside with radioactive material, do not enter on it by the time it came, things like that. So it was exciting. I mean, I enjoyed every bit of it, excepting for the worries which you always have when you do anything experimental. So anyway, it got done. And the confidence which my professor had in me was amazing. I sometimes didn't have the confidence which he had in me. Once he had decided I was going to do it, he would meet me once in 15 days or once in a month and say, "Go ahead, you're doing great." That's about it. He was so busy, I'm telling you, it's hard to believe. He had to go to Washington very often and so on. He had a company of his own also, by the way. So, it took its time getting the money, setting it all up. The whole year went in all that, more than that, in fact. And all he did was he used to meet me once in 15 days a month, encourage me, get a 5 minute or a 10 minute, what you call, explanation from me of what was happening. And that continued. I mean, for the next year in which I set things up, the difficulties I had, the what you call, which you all have in experimental setups, they went on and on. And at times I almost felt that things wouldn't work out the way I wanted them. But that's when he came in. He said, "Look, uh, don't give up." He said. I once met him late in the evening. For a month, I'd been having difficulty with the vacuum system, with some thing or the other going wrong, and I was feeling down. So I met him, and he said, "Look, if anybody is going to fix this, you are going to fix it. Okay, and I know you're going to fix it. So just go back and carry on. You're doing great." He said. Now that's the kind of confidence you need. You don't need a guy who will scold you and say, "What's going on? 3 months have gone by and you haven't got any results." That kind of thing. So he showed me how to deal with students. The second thing was, when it came to money matters, we had to buy so many things. And, he was the principal investigator. I was the research assistant. And there was a rule at MIT that anything costing more than, I think, $100 or was it $200? I've forgotten. The principal investigator had to sign it as when you wrote the bill for ordering it, the indent. So the first time that had to be done, I went to him or left it to his secretary. He signed it, and it was back through the secretary. She called me up saying, "Take it." He signed it. And the next time I did that, he called me in. It was in his office right at that moment. He said, "Why don't you ask him to come in?" He was busy with something, but he said to me, "This business of signing, what's all this?" He said, "That's the requirement." "Oh, forget all these requirements." He picked up that indent book I had. There were five what you call blank indents. He signed all of them. He said, "That should do the trick for 2 months for you, right?" I said, "Yeah, sure." He said, "Go ahead. You shouldn't have to spend time on taking my signature and such things." So that also tells you how to deal with people. You see, you size up people and you say, "Look, at this point, he's going to take over. I must have the confidence in him. It's not going to run away and do something wrong." So the confidence he gave me was how to deal with people, how to size up people. It's not that he was nice with everybody. I've seen him scold students also later on. I saw him doing that when he thought that the student wasn't performing or wasn't caring about what he was doing. And his general attitude of getting the best out of you, encouraging you, and yet keeping just enough watch to see that things went well. So it was a great role model for me for all that I've done later on in life. So he was another great influencer, a great person who influenced me to say, "Professorships are good." I said, I'd like to be one. That's the way I left MIT. So I think that gives you an idea. I think that mentioned the persons who really influenced me in a big way.
Sir, it was very inspiring to hear about your thesis advisor at MIT and
Yeah.
your interactions with him. Sir, moving now to the IIT Bombay campus, what were your first impressions of IIT Bombay when you joined as a faculty member in October 1965?
That's an interesting question you've asked me. And uh, let me let me tell you, I joined the institute. By the way, I always remember the date. I joined the institute on a Monday, October the 12th, 1965. Okay? And of course, when I joined, I came to the institute by staying with my aunt in Kolaba, and her husband, my uncle, said, he hadn't been on the IIT campus ever, but he said, you'll have to get down, take the local, get down at Vikhroli station, and take a taxi from there and go to the IIT. And that's all I can tell you, he said. And that's what I did. So I joined on that day. And the taxi, when it entered IIT, we came up the slope, there's a hill. IIT is at a higher height than the surrounding Bombay Agra road in which we came. And the moment I uh, came up the hill and turned in through the main gate, it was 1965, so the campus had been built partially. And I drove through the road which leads up to the main building. And there were these palm trees on both sides, They were there right there. And I must say, I loved them. First sight, you like that thought. There weren't too many trees on the campus then, by the way. 1965, it was quite barren. But that sight of palm trees on both sides, and then a little later, I saw the lake, and I stayed in the staff hostel, and the staff hostel had just one wing at that time, and my room overlooked the lake. So in the evening, when I came back after a week, I came to stay at the staff hostel. The sight of the lake, the calmness of the lake, if you walked along the lake to see the sun setting on the lake, that's one first impression which stayed with me all my life. The beautiful surroundings in which we lived in the IIT. The lake, the hills, and later on the greenery also, which came as we were there and we planted so many trees. Something that I love to this day. It is something that captured my mind right from the first day. That was one first impression. Great campus, I said. I've made a good choice. I mean, at least in that sense. Then some other things that struck me were, you join, and then of course I went to the department. Fortunately, I had no teaching to do immediately. The semester was on. Half the semester was already over in October. About half was over. So I had no teaching to do in the first semester. So I had time. I could go to the library, see what books were there, meet my fellow faculty members in mechanical engineering, which I did one by one, meeting them, coming to know them, introducing myself, and so on. And that was good for me, to get that time to settle down, 2-3 months to settle down. And then when I met them, the first thing that struck me was that they were all very serious about their teaching. It was quite interesting to see. They used to, when I asked them, a few of them that I came to know immediately, they were quite serious about what they taught, how they taught, and so on. And I said to myself, this is a very dedicated group of people. By the way, they were all mostly young then. We had just 2 or 3 senior people in the department who had been teaching in other colleges earlier. The rest had all joined the institute in 59, 60, 61, and they were, either in their early 30s or late 30s, that kind of thing. So they were young, relatively young. All had come with the intention of starting something new, building labs, setting up labs, etc. That's what their intention. And that was one thing that made a deep and a very good impression. Uh, then the third thing that really impressed me, immediately, I mean, I didn't experience this because I didn't teach immediately. I came to know through my colleagues that the teaching, we had complete academic autonomy in our teaching. Like you have in an American university. There's an instructor, he teaches the course. He sets all the tests, the quizzes, the some exam, and he grades you. At IIT Bombay, it was exactly like that. I mean, we didn't have that many tests and quizzes at that time, but the instructor, the teacher, or the professor teaching you was everything. We had that academic autonomy. You teach the course of one semester. At that time, some of them extended for 2 semesters, it was a whole year long. You set the exam papers, you correct them, and you give the marks at the end of the semester. That was the way IIT Bombay was structured. And that's what I call academic autonomy for teaching. And this was something that struck me. I hadn't expected it because in BHU, we had an old-fashioned university. The syllabus was there. The teachers taught you from that syllabus. Somebody set the paper at the end of the year. You never saw that examiner or the paper setter. And a month or two later, you came to know your result. That kind of thing. Here, the teacher was your examiner. He gave your marks. And I liked that because I'd been to the US where this was the case. So it was a very pleasant surprise for me to see that IIT had academic autonomy when it came to teaching and even the content of the courses right from the beginning. And, there was a Russian influence at that time. The USSR had given aid to IIT Bombay, equipment, experts. Some young professors were sent to the USSR to do their PhDs and so on. But this academic autonomy was, I was told, something that was similar to the USSR. There also teachers taught and they graded. That was the way it was done. So it was a very pleasant and a very, shall I say, nice surprise to have when I joined IIT. And as I said, it was good to, uh, to experience that. So these were first impressions. Of course, within a few months, everybody would always ask me, "What do you find IIT Bombay compared to MIT?" It was a question which, like the other question which everybody asked me, "Why did you return?" It was something I got used to, and I had my own replies, which you have seen. I didn't explain in that much detail to most people, but the point is, this was a question people asked. Oh, you were at MIT, great place, how different is IIT Bombay compared to MIT? And is it anywhere like that? And things like that. And uh, I used to always tell people, I used to say, look, MIT is 100 years old. In fact, MIT celebrated its centenary in 1964, the year I finished my PhD at MIT, my Doctor of Science. So it's not fair, I said, to compare MIT or IIT Bombay with MIT. IIT Bombay is 7 years old. It's just the first two batches or three batches have just passed out with BTech degrees. We hardly have a postgraduate program going still. We have no PhD students. So it's not fair. Let's not make such comparisons at all. So that was something which I told them. But in my mind, I knew straight away that the institute, IITs, were set up, as you know, to become in future like MITs. So that's a sentence in the Sarkar Committee report which suggested the opening of the IITs. That IIT should aim to be set up and be set up along the lines of MIT in USA or the Imperial College in England. So in my mind, I knew that while the teaching was good, while IIT Bombay had a good undergraduate program then going, which I could see, it had a long way to go when it came to postgraduate studies. IIT Bombay had a long way to go in terms of research, to get PhD students, to get research going, to interact with the industry, to get projects going of that type, to have sponsored research. All these things had still to come. So while we'd made a good beginning, the institute had a long way to go. That was very clear to me. And so, if you asked me at that time, my mind already knew what things I had to do. Because if you've seen MIT, you know what you want your institute, if you've joined it, to grow into. So these were some first impressions which I'm giving you. And I hope this is a gist also, but these are the principal impressions which tell you how I saw IIT Bombay right away at the beginning.
It is great to hear your initial impressions of IIT Bombay. So your main areas of work have been heat transfer and later solar energy. Would you please recollect your teaching and research experiences over the years, particularly your initial experiences? Could you please also tell us about the textbooks you wrote? What were your specific areas of research and how did they evolve?
Now, in my first full semester at IIT Bombay, that is started in January of 1966. I had a postgraduate course to teach. It was on instrumentation and measurements. This was for the thermal engineering group, which was doing MTech in thermal engineering. There were about, I think there were 15, 20 students in that class. You teach things like, I taught the part concerned with thermal side, that is temperature measurement, flow measurement, pressure measurements, what are the ways of calibrating instruments there, how to make the measure different ways, how you select instruments for particular situations, and so on. And there's about 15, 20 lectures that I gave. It was good. I mean, the students, 15 or 20 postgraduate students are very, they listen to you. It's not an undergraduate class. You've been an undergraduate here, so you know the difference. So it was good. I mean, there were a few questions, not too many, and but I enjoyed the teaching. I used to prepare very carefully for those lectures. It was the first time I was giving a full course from the point of view of grading and so on. And I prepared every lecture would take me time. I knew the subjects. It's not that I didn't know how temperatures were measured and flows were measured or pressure measured. I'd used all kinds of devices in my PhD work, so on. And even prior to that, in the research project I worked with at MIT. So it's not that I didn't know what was there. But teaching is different. You have to start from certain principles, explain the principle of working of that device and so on. So I spent quite a bit of time. Every lecture that I gave at that time, I remember, I used to spend easily 2-3 hours to prepare my notes. And it paid off because in the process, you yourself learn something. Teaching something for the first time is also a learning process for you. You think you know the subject, but you know it only partially. You keep on improving as you go along. In the first time, there's a lot of learning that you have to do if you want to teach well. That was the first semester. But it was the second, the next one, which started in July, where I taught an undergraduate course in heat transfer. And that was a class of, I think, probably 70 students. Fourth year. That was a 5-year program then. So this was in the fourth year, first semester. And, these are boys. There was no girls in that class, I still remember, that first batch. And in fact, mechanical engineering always had very few girls, right through. Now there are many more, which is good. But at that time, there were no girls in that class, I remember. And 70 students who were perhaps about, let us say, 8 or 9 or 10 years younger to me, not all that much younger. Okay. And they can be rowdy. Let's be clear if they want to be. So, teaching the course again took a lot of effort. There were books in the library. I had my own books also, which I brought with me from the US. I added 1 or 2 Russian books which were there in our library because they had given books. And I had to prepare, as I said, quite a bit. The previous year, by the way, just as an experience, as an anecdote, I'll tell you. The previous year, a Russian expert who was here taught the course. He's a good person. He was not really in the field of heat transfer. He was more in thermal power engineering. And but obviously, you know your heat transfer. You can teach a course. So he taught the course. And he'd used a Russian textbook, Mikhail, well-known Russian book. And he obviously, when I met him, he was still there. He hadn't gone back when I joined. He showed me the book. I bought the copy of the book, and I saw it, and it didn't quite make the impact I wanted. You see, and straight away I need to tell you that MIT gives you, when it teaches a course like heat transfer, it teaches it as a science and as an art. That means you are an engineer, but you need to know the science of the subject first. You need to know the basic equations first. And then you say, look, equations can take me up to a point. At a certain stage, I need data from which correlations, equations are developed based on experimental data. And I may have to use a lot of that if I want to design equipment or whatever it is for industry. So you need to teach the subject as a science and as an art. And that's what MIT does for you. In fact, I'm taking over a little at this stage what I was going to say later. But this means you've got to tell first governing equations which govern the topic. You're teaching conduction, you've got to do Fourier's law of heat conduction. Solve a few things analytically. If you're teaching convection, you've got to at least state the Navier-Stokes equations valid for laminar flows and go through that. Then you may go to correlations, which are used a lot in designing equipment. When it comes to radiation, you need to teach the basic laws and show the dependence of radiation on wavelength, direction, etc., etc. So when I saw the Russian book, which I thought was largely practice oriented, I knew straight away that while I would use a few of the equations given there or give them to the students, I was not going to follow that way. I was going to follow the MIT way. I mean, that was already ingrained in me. And so I taught the course the way I wanted. As I said, IIT Bombay, nobody told you what to teach. 30 lectures, I think, 300, probably there were 40 lectures or so in the course that time. And I planned it, saying how much I would spend on conduction, radiation, convection, etc., and taught the course. And as I said, once you start teaching it, once you start teaching from the basics, it was amazing how quickly the class appreciated it. They could appreciate it because they could see that the physics they had learned earlier wasn't to be left like that. And I would just say, here's an equation for calculating if this is the heat transfer problem. Here's an equation for calculating what will be the heat transfer rate if it's a radiation problem. That's the way you teach it empirically, where you don't want to understand the basics. But if you go to the basics, you can derive equations for certain simple cases. Then you can go on to more complicated cases and say analyzing them is difficult, or analytically you can get up to a point. Those days there were really no computers worth talking about. And so you need to therefore have practical experience and use equations based on experimental data. Once you take this approach to teaching, it's amazing how well an undergraduate class takes to such a course and enjoys it. Okay, and so I enjoyed it gradually as I went along. Of course, in those days there was no attendance problems. Nowadays, IIT Bombay, one of the major problems is attendance. Everything is online, everything is recorded. Many people think they can always see, what is already online or available online, and they can do without it. There's no such thing. There's no substitute for a good teacher. I keep telling people, and I think I'm right. So the class of 70, I tell you, after a while really enjoyed the course. I enjoyed teaching it because there were a lot of questions, let me tell you. Very often I had to spend time thinking over the answer, and I used to often tell the student after the class, please meet me after the class, or I'll think over it and let you know in the next class, things like that. And they appreciated it. But there were more to the class than that, which they remember me for, the early classes. When it came to the mid-sem, there were no quizzes, as I said at that time, mid-sem and a semester end. When it came to the mid-sem, I said, look, I'm going to give you an open book exam. And they never had open book exams till that time. So I said, open book means only this. I'm going to let you bring to the class a sheet of paper on which you can write what you like. All the formulae we've developed, all the equations I've developed, whatever you want, it's yours. But what you write on that sheet, you can't lend to your neighbor while we are having the test, the mid-sem, or even in the final exam. I'm going to follow the same practice. So you write what you like based on your notes, bring that and use it. And the intention is that you shouldn't have to memorize by heart, here and there some formulae or some derivations that I've done. You don't have to memorize them. You can write those down on a piece of paper. So the moment I said open book, half the class thought it was nothing. Said, open book, what's there? Straightforward. And so the exam came, and I still remember it was an open book exam, in which nothing that I derived in the class or nothing that I'd done in the class was asked. There was more to it. Every problem that I gave required just that little bit more thinking beyond what I'd done in the class. And they had to think. And some of them could think through what I had asked. Some of them had difficulties. But again, they remember me saying they made her open our eyes, and we don't mind. Of course, I was lenient in grading it. You shouldn't be too strict if you've surprised them with an open book exam. And you say, look, if you've made one small mistake, I'll give you 0. Many instructors used to do that in the old days. when there was an answer, 3.300 or whatever it is. If you didn't get 3.300, say your answer is wrong. You got 3.42 or 3.31, zero. You know that. I didn't believe in that. If you know what you're doing, give some credit. So if you grade it fairly, I mean, you still make your point of what an open book exam means, and yet they don't mind. They're ready next time, they're better prepared for what they're heading for. So the initial, I've given you an idea of what it was like initially. And I must tell you that joy of teaching a class of 60, 70 students, and that joy of teaching later on even postgraduate students, where the classes were bigger and I had to teach the same course with a few more topics and so on, remained with me throughout my career. It's never left me, never left me. And of course, I taught other courses. I taught the course on thermodynamics later. I taught a course on solar energy and its applications. I used to teach instrumentation and so on, thermal instrumentation from time to time, or take the lab and so on. But the joy of that teaching a class of 60, 70, getting questions from them and answering them, or meeting the challenge of answering some of them, is something that never left me throughout my life. And so long as that is there, so long as that joy never leaves you, you enjoy your job. And what more can you have? You're doing a job for you, which you're getting paid, and you enjoy it. You enjoy being a professor. So that's one side to IIT, your teaching experience. Don't look upon it as a burden, for heaven's sake. To all new people, I say, think of it as something as a challenge. Meet it, whatever be the disappointments. From time to time, you are disappointed with some students, but meet it as a challenge. See what is in the minds of students. Try to get to them. Try to get some of them at least interested in your subject. And when you do that, you enjoy it, they enjoy it, and you can't have a better combination than that. So that's teaching. Now I move on to the other part, that's research. You've asked me what were my research experiences. And you remember what I told you. My early assessment, IIT Bombay had almost no labs worthwhile for doing research, particularly experimental research. In heat transfer, almost nothing. So you have to build up the lab. You have to literally borrow instruments from some other labs, ammeters, voltmeters, which would measure power being given to a heater, some millivolt meters for measuring the output from thermocouples, pressure gauges. We had some, I remember, quite a few good ones to measure pressures. Make your own devices for measuring flows of air, orifices or nozzles, things like that. We had to buy some instruments, some for measurements, but literally it was starting from scratch to get any worthwhile research going. It took almost 2 or 3 years before that could be done. And then only I could say that the first MTech student with me did a project with me and so on. And I could, say that, something worthwhile was being achieved. And I don't know if you remember him, but Professor G.K. Sharma, if some of you would have met him, I think he retired around 2004 or 5. So if you were earlier to that, you would have met him at some stage. He was my first MTech student. He's a young lecturer then, about 5-6 years younger to me. So uh, it was you had to think of the problem which you wanted to do. You had to see that it was something that wouldn't require very complicated or sophisticated instrumentation, and then get to do it. So it took some time to set it up. So I'll come to the areas of research in a moment. So that was the challenge of doing research. And as I said, it took some doing and to get the things fabricated. Fortunately, in my laboratory, I had some very good mechanics who could do things after being, told what was wanted. Things like welding, machining, etc. I could get them done. They were slow, but they did it well. And if you insisted on quality, well, you got quality. That's the way I see it. And they would do what I wanted. So that proved to be a great help to me in all the research work that I did. Because quite a bit of what I did was experimental. So that I think I've covered the thing about how research got going. And let me now move on to your other part of that question, where you asked about my research topics. Now, again, I'll have to be brief. Areas in which I worked, well, an area in which I worked quite a lot was an area of forced convection. Now, you'd say, what's so great about forced convection? You see, fluid flows past a tube, cross flow or whatever it is. Heat transfer takes place either to the fluid flowing inside the tube or flowing out of it. And you've got correlations for calculating what the heat transfer coefficient is. But there are many situations which are always worth studying, more of them. For instance, if it's a turbulent flow, or rather, let me first take another case. For instance, suppose it's a very hot tube or a reasonably hot tube which is giving out heat to air. Air is flowing past, but not at a very high velocity. You've got forced convection, but at a low velocity, you've got a low Reynolds number. And because it's very hot, you've got heat being lost also by natural convection. So you've got a combination of the two. The natural convection and the forced convection may be in the same direction. That means the tube, if it's horizontal, the natural convection flow is upwards. And if the flow is also coming from below and going up, they're in the same direction. They can be opposed, they can be at right angles. So you see, you've got a variety of problems in practice where this happens. We call that combined convection or mixed convection. In these 60s, late 60s and 70s, which I'm talking about, that was a relatively a new topic. Some papers were just coming on that. So really, that was an area in which I worked with various MTech students, then a PhD student. Some part, much of it was experimental, but a small amount also. By that time, we could go to TIFR, use the computer. So I had one student who actually used to make the long journey to TIFR with his writing his program on cards and getting it done there, and to do the numerical work on the differential equations. So that was one area of work, mixed convection, and I worked on that for many years. I'm described it in brief only to you. I'll just take two or three other areas. Another area in which I worked quite a lot, I thought, was heat transfer in thermal insulations. All of you have seen, say, thermocol used for insulating low temperature, at low temperatures, refrigeration temperatures. All of you would have seen fiberglass insulation used for insulating pipes which are having steam flowing through them at high temperatures. All of them, if you've gone to a factory of any kind, would have seen hot pipes with some other kinds of insulation. Now, heat transfer through insulations is a topic worth studying, particularly if it's, say, a fibrous insulation made of fibers. If it's made of fibers, it's really the fibers are very thin. And inside the insulation, there's convection, there's radiation, and natural and what you call conduction taking place. Outside, if you just put that insulation on a pipe, you see only it as a conduction problem. You say, this is the thermal conductivity of the insulation as given by the manufacturers, and I'll use that value depending upon what is the calculation to be done. But in reality, as I said, inside, if it's a porous insulation, and many of them are, you've got phenomena taking place, all the phenomena taking place, convection, radiation, and conduction. And it's a problem which is worth analyzing if you get into the depth of it. That's what we did. Again, I had a series of what you call MTech and PhD thesis on this topic, and it didn't happen in 1 year. I mean, I've kept on doing this for 7, 8 years, worked on it. That was one side of it, of, analyzing what happened inside insulations and trying to see the mechanism, studying the non-isotropic nature of how they worked, and so on. There's another side to it, and that's where you also had to deal with industry a little. Industries need the K value of the insulation. K value means the thermal conductivity of the insulation, usually as a function of temperature. Someone will come to you from industry, sir, we are making this fibrous insulation. We want to know its thermal conductivity. Now, in practice, if you look at it just as a theoretical problem, so set up a one-dimensional situation, and have heat flowing in one direction, measure the temperature of the insulation at one end, the other end, get the heat flow through the thing, and calculate K. apply Fourier's law of heat conduction, one dimensional. Straightforward. But in reality, if you want to do this accurately, say to 1 or 2%, making that measurement is quite an art. There is what you call a standardized method. There are standardized methods of measuring the thermal conductivity. The one used most is called the guarded hot plate method. And basically, what the standardized method does is it ensures that the heat flows only in one direction when you do the actual testing of that insulation. And for that, you have to ensure that there are no temperature gradients in the other direction. So you need outside the insulation which you are testing, you need another plate which is kept at the same temperature and prevents heat from flowing in the radial direction. If it is, say, a circular cylindrical slab that you are testing, and so on. You understand? So it's a standard method used all the world over. And in India at that time, the guarded hot plate method was being used, but people didn't have the instrument. It was a costly instrument to buy from abroad, and I was familiar with the instrument because the company in which I worked later used to make them when I worked for a year and a half. So it's actually seen the instrument being used abroad. In principle, as I said, there's nothing to it. In practice, making it is a job. It requires careful doing. So I said to myself, we should be able to make it. It's a slow transient. You see, that's important when you don't have high-class instruments with you, which act fast. So it's a slow-moving transient. I said we should be able to make it. So that was a good MTech thesis. I first had somebody design it. I think it was a BTech project. Then I had somebody build the instrument, the setup, not in the instrument, because we had the necessary millivolt meters and other things for measuring the heat being given and so on. And then I had another MTech student who tested it out, that kind of thing. And it took its time, but it was a good challenge to make something which industry wanted. There weren't that many requirements, but it put me in touch with the manufacturers. Those who made fibrous insulation came to us over the years, wanted their insulations tested. Those who were doing other types of insulation also came, which were at higher than room temperature and so on. So it was a good experience because I came to know those people. I visited their factories and so on. So it was one area in which I had some interaction with industry, which also made me see what are the issues, how they manufacture the insulation, actually by visiting the factory and so on. And I was also on the Bureau of Indian Standards Committee for it, so that when they meet for modifying the standard which we had in India, they need experts. So I was on that committee on it for a few years also. So you see all sides of the problem, which you think in theory is just a one-dimensional problem. So this is just to give you two areas of work, mixed convection and this. I'll now just talk of one more area of work because I moved on to solar energy in the 70s. So it's important that I speak a little about my work in solar energy. And this was more applied. The solar energy work I did was more applied, not that basic. But one thing which I thought I should do, and for which we were funded by the Department of Non-Conventional Energy, by the government, was I said I'll build an absorption refrigeration system, a cold storage refrigeration system, 1 ton capacity, 1 ton refrigerating capacity, which will run solely on solar energy. That means I'll have flat plate collectors which heat water up to 90 on the roof. I'll heat that water, store it so that I have heat available for 24 hours, and then cool that room, bring it down to about, I was estimating about between 5 and 10 degrees centigrade, and then take data on it, seeing how its performance would change as you tested it over 6 months, 1 year with the weather outside and so on. It was a big project. One of the big ones went into quite a few lakhs of rupees. Of course, at that time, late 79, 80, a few lakhs of rupees was a big project. Today at IIT Bombay, if you say you've got a few lakhs project, nobody looks at you, everything is in crores. That's how times change. Anyway, it was a very challenging project. The institute, if you take such a thing, it sounds so easy. Build a room, get flat plate collectors, install them, have instrumentation for measuring their, output, build your an ammonia absorption system for that, because it had to be made based on my requirements, and then test it out. And believe me, it was quite difficult getting the things going and me making. Right from building that room, which the institute built for me, it's probably still there at the back of the IC Engines lab, that room, being used for something else now. But I did this through a series of MTech and finally a PhD student. I and my colleagues, I didn't do it alone. I had other faculty members with me on that. And the first tech student had to design everything. The second to start building it and just do some preliminary runs at the beginning. The third to do some preliminary testing and get some data. And then later on, I think there was a PhD student which I didn't guide. One of my colleagues guided, who took more data on it. That's how the project went on for about 4.5 years, in which we got data and did a reasonably good job. But as you know, that turned out to be something that wasn't viable. Commercially, the cost of flat plate collectors never went down. And so long as they were the major contributors to the cost of the system could never be competitive. So while it worked, it also became clear that you couldn't have an ammonia absorption system running on flat plate collectors. You needed a source of heat at 90, the heat coming from other source, not from flat plate collectors. This was developmental research, but still very, very challenging to do in an institute. And a whole lot of students were interested. I used to have the best students who would work day and night with me on that project as it progressed. I could talk of other things, but I think I've given you a gist of three areas. I could add more, but let me mention one more, and that's because Uday Gaitonde is sitting next to me. Another area which fascinated me was measuring the thermal conductivity, not the thermal conductivity, estimating or measuring the properties of mixtures. And with him, that was his PhD thesis, by the way, we were interested in measuring the thermal conductivity of liquid mixtures. Now, it wasn't just a matter of taking any liquids. You see, if you mix generally two types of similar liquids, I would say, let's say both are non-organic and don't have difficult. Let's say they are organic. Most of the liquids we were interested in were organic. They'll have different molecular structures. And the general thought till then, when you had a mixture which was being used in practice, was to use some kind of a weighted mean to calculate the thermal conductivity of the mixture. The weighted mean could be in terms of the relative mass of the two which you used, or the relative, try to bring in there some other property into it, not just the mass. For instance, thoughts had been expressed that the thermal conductivity of mixtures could be influenced by these molecular structures. And that's really where we added on a little to our knowledge at that time. The co-guide in this particular project was Professor Deshpande of chemistry department. And he was the one who suggested particular liquid mixtures where we would be having this set of mixtures where the molecular structures would be different, in the sense a ring structure and a linear structure. Now, I may not remember the details now, which ones we tested and so on. But the point was, it was a thesis in which the originality lay in pointing out that the thermal conductivity of the mixture couldn't be estimated well if it came to mixtures just based on the relative masses of the two in the mixture. Couldn't be done on that. You needed to go to more than that if you wanted to do a better job than just, say a better job than say 10% on that, 10% estimate than that. And so that was a contribution, and it was a good contribution, which was, as I said, Uday Gaitonde's PhD thesis at that time. He worked on the subject later also to some extent, carried it on. But I thought I would mention that. When I was teaching heat transfer, I taught the subject of heat transfer in a row continuously, 1966, 67, 68. I think at least for 4 years in a row I taught the subject. Maybe I took a break for 1 year. A colleague taught it, and then I came again. We used to alternate after that. And when I wrote the book, the first thing that I realized was that I was making my notes from different books, and of course adding some of my own problems as we went along, not just using problems from problems solved in books that I read. So gradually it came to me that my method of teaching, presenting things, uh, and what I took from different books, the problems I solved, were all adding up to a nice textbook. And somewhere around 68, I said, why don't I start writing these notes in a more compact fashion and make a book out of them? And so I started writing. In the evening, and I regularly kept on writing the book. It was supposed to be a textbook on heat transfer. We've kept the same name still. And that book I wrote, I think it was published in 1970 first. The first edition came out. And it's gone into 4 editions over the years. The fourth edition came in 2005. And you can see the book now, right? That's the fourth edition, 2005. Okay? And the book made a good impact. Fourth edition, as I said, was 2005, and that's it. After that, I've retired, and the book is still being used some places. But naturally, if you don't what you call add on something to it, other books are coming along. It's still being used. So that was one book which I wrote, and many people, when I still meet them, if they've been students in other colleges, etc., in the universities where some places it was prescribed, the moment they come to know my name, they'll say, "Oh, we studied your book," that kind of thing. It happens still from time to time. It's nice to know. Now, the other book I wrote, was on solar energy, and with emphasis on the thermal applications, because my area of work was primarily that. What I mean is solar energy is the direct use is through thermal applications and through photovoltaic route. Now, while I used to teach in the class the photovoltaic application also, my research work was almost all on the thermal side. So again, the same thing. I mean, this was a new subject for teaching, even in other countries. There were hardly any books when I started teaching the course. First, I think in 1978, I started teaching the course, or maybe 77. There's hardly a book from which one could teach. You had to pick information, to read a few papers to add on to the latest work, and so on. We had a few journals coming, like the Journal of Solar Energy. And so, that was something which I had to work a lot for that course. But it again turned out to be very good. I remember the best book written at that time for thermal applications was one by Duffy and Beckman from the University of Wisconsin. In fact, I met both of them once. They'd written a good book. It was for students primarily. And it was the first place where systematically they tried to show what could be analyzed, what couldn't, what had to be done empirically, and so on. So I used that book when I taught first time. But again, you see, that book was written for students in America. So I wrote the book, and again, as I said, the first edition was printed by Tata McGraw-Hill. I think it was in 1983 it came out, or 84. And after that, again, I've updated it from time to time. And the fourth edition did come out a few years ago. And of course, I've retired. So I had a colleague of mine, Professor J.K. Naik, who's also retired now, by the way. He was my colleague for writing the third and the fourth edition because he was more up to date with some of the latest references and so on. So that book has also done well over the years and still very much in print. The fourth edition came out, as I said, in 2016. That's the fourth edition, which you see. Solar Energy, the fourth edition, and you see both the authors' name at the bottom. It's again been widely used in India, used for design purposes because we describe in great detail how one goes about designing collectors, flat plate collectors, concentrated collectors. No other book has gone to that much detail because I thought it was useful to give this because
Sir, it was very inspiring to hear your description of your courses in the early days of IIT Bombay, and it is very inspiring to hear your descriptions. Even though I don't understand too much of mechanical engineering, I could actually see your passion in explaining those topics. So, moving now to a more general issue, how would you describe the evolution of undergraduate curriculum in engineering at IIT Bombay over the years? What was the curriculum like during your undergraduate days at BHU in the 50s and at MIT in the 60s? Did your education at MIT directly or indirectly influence the undergraduate curriculum design at IIT Bombay, with which you were closely associated, sir?
Yeah, yeah. Well, that's a good question. Let's take up this question now. The curriculum. I'm not talking about the UG curriculum. All right, that's clear. And the PG also. I mean, we've done many things over the years. And as I said, I've had a variety of students. Just to tell you, I must have guided at least over the years 100 BTech students for their BTech projects over the years. I must have over the years guided probably about 40 or 50 MTech students. And over the years, I think I guided 19 PhDs. So you see, all sides have been covered over the years, right from starting in the late 60s, right up to about 1996. When I was the director, then I stopped taking students, really. That wasn't the time, and I thought I wouldn't be doing justice to my students by taking research students then. So it's been this curriculum making has been something that always fascinated me, the curriculum. And broadly speaking, if you look at any curriculum, in engineering, you will see that the breakup of the subjects you study, the courses you study, is something like this. You teach courses which are what we call basic and applied sciences in the curriculum. That means subjects like mathematics, physics, chemistry, nowadays even biology. And you may take them a little beyond what's taught in 12th. That means you are teaching a basic part of the subject. Or you may not, in the engineering curriculum, take them beyond what is taught in 12th in terms of physics or chemistry, but teach the applied part of the subject more. And that's called applied science. That's one part of the curriculum. In the first year, second year, these are the courses taught. Then the engineering takes over. Your discipline, whether it's mechanical engineering or electrical engineering or whatever it is. In mechanical engineering or something, or in any of them, you first teach what are the engineering science subjects. Okay, what are these? In mechanical engineering, the engineering science subjects are, thermodynamics, heat transfer, fluid mechanics, solid mechanics. These are the basic subjects you teach, which we call engineering sciences. And from these, you build on to the applications. If it's thermal applications, you teach subjects like energy conversion, thermal power conversion, refrigeration, air conditioning. This is the thermal side. If it's the design side, you teach how to design machines, all right? And then you need subjects like design, how to design them, how to use computer-aided design techniques, and so on. But the basics come from subjects like solid mechanics and fluid mechanics, or thermodynamics and heat transfer. Then you go on to subjects. Once you've covered these are what we call as the departmental core. That is the engineering sciences and the engineering applications. There are electives in this also which you take because you can't teach everything. And usually that takes the major part of the curriculum. The major credits are on this part in any curriculum in engineering. And then you, depending upon where you're from, there is some humanities and social sciences. The degree of how much is taught varies. In some places, there's none at all. No humanities, social sciences was taught or is taught even now. In some places, it's just a few percent, and that too of an applied nature, like a subject like economics is taught because engineers should know a little economics, that kind of thing. Or certain amount of humanities and social sciences is taught because it is considered that a well-rounded engineer even at a bachelor's degree level, must have a certain appreciation of the humanities and social sciences. You may learn sociology, you may learn psychology, you may learn some subjects like that, or other subjects like economics, but you should learn subjects like this, so that you appreciate the world, or you are not a misfit in the world in which you're going to move to as an engineer. And then, of course, as in engineering, you have to learn some what we call as professional skills. That means you have to learn a little bit of workshop. At least in the old days, you had to. You have to learn quite a lot of drawing. You must be able to draw what you design as an engineer. Then you must be able to nowadays, not nowadays, but still, uh, some computer programming and utilization, some basics of electrical engineering, if for instance, whatever be the engineering profession, the specialization you're going to work with, you need to know all this. These are engineering skills, workshop skills, drawing skills, design. I mean, electrical engineering basic skills. Doing some programming. These are skills. Now, if, just to take go back 50 years, when I did my, more than 50 years, when I got my bachelor's degree. At that time, the we were not taught anything in physics or chemistry beyond the basic physics and chemistry taught up to the 12th level. So all the physics we learned or the chemistry we learned, there was no biology taught to us then, was all applied physics, applied chemistry, which was useful in our engineering practice. Like you learn something about the iron carbon diagram in applied physics, because when it comes to heat treatment and so on, and castings, you need to know something about the structure of iron, steel, malleable iron, and so on. Things like that, or other diagrams for other things, not just steel and iron. So applied physics, applied chemistry were the subjects we learned then. But we had no what you call basic physics or basic chemistry. There was no solid state physics, no electronics taught to us then, nothing of the kind. Everything was on the departmental core and on professional skills. Departmental core subjects like, again, we didn't have full-fledged courses in thermodynamics and engineering, heat transfer. These were taught as part of the applied stuff. When you got something that required a conduction calculation, they'll say, we use Fourier's law and this is the equation for calculating the heat lost from a pipe. You understand? So heat transfer was not taught as a separate subject. Thermodynamics was not taught. When it came to energy conversion, they would say, well, the first law, we apply, how much energy is flowing in, how much is flowing out. This must balance this if it's in the steady state. Therefore, the work done, which is the difference, is what is the output of that power cycle. Things like that. The first law was not taught in depth. Thermodynamics was not taught in depth. The only thing was, since there were some descriptive questions, we all knew the second law by heart. There are two statements of the second law. A typical question under write short notes on the second law of thermodynamics. It used to be a typical descriptive question, the type which one shouldn't ever set in engineering. But so we knew the second law by heart without really understanding the depth of what it really meant. So you follow what I mean, that engineering was taught from a very practical standpoint. We knew how to use handbooks. We knew how to design, what factors of safety to give in different designs and things like that. And then we were taught professional skills. Workshop practice took a lot of our time, and we enjoyed it, by the way. Workshop was the most delightful thing. In the first year when we first went into a workshop, all of us were a little scared. And nothing. After a while, you really enjoy your workshop. Whether it's machining, whether it's doing carpentry, whether it's doing foundry, blacksmithing, whether it's doing some electroplating. We've done everything in Banaras Engineering College and enjoyed it like anything. So that was fun, but we had to do it. The thinking was, you're going to go out at that time as a maintenance engineer, as an engineer who will repair things. You should know how things are done and how workshops work. That was the thinking. You understand? And so we had to do a lot of that, so that if you go out, at least you've handled a lathe once or twice in your life. You've handled a milling machine. You handled a shaping machine. Though, of course, in these machines which are costly, we were not allowed to set them up. The instructor would you tell us to do it and then help us to do things, because he didn't want us to suddenly do something wrong and spoil the machine and things. Excepting the lathe. The lathe we had to learn how to center a job, how to do turning, how to do cut threads. We had to do that. Okay. So that's how things went. Now, so you see, the emphasis then was on two things. Learn applied, three things. Learn applied science to the extent it's needed in your engineering. Do the departmental core, which is largely design of machines, design of equipment, steam turbines, steam engines, IC engines. We had to design them, draw them with cross sections, everything. And I must tell you, we enjoyed it. It's not that considered it to be a bore. As a mechanical engineer, I learned structural engineering. I could design a decent bridge, a structural bridge, made with riveted joints in those days. By the way. Okay. And if you want to see a riveted joint still, I think it's a Tilak Bridge in Dadar is a riveted joint bridge still. And railways, many are there. They're well maintained. No reason why they can't last longer. So that's the kind of engineering we did. When I went to MIT, suddenly things changed. You see, the curriculum was more science oriented. There was much more physics and chemistry, mathematics in it. Okay, we were taught only applied mathematics. We were taught mathematics. I should mention that in Banaras, but all applied mathematics. How to integrate, how to differentiate, things like that. A little bit of statistics to use in certain problems, things like that. All of an applied nature. So MIT, though I was not an undergraduate, I took a few courses here and there or listened to them. We were allowed to attend them. And I could quickly see the difference in emphasis. The emphasis was always try to see the science behind the problem, try to analyze the problem, and then do it. If you have a problem in heat transfer flow, you put down your conservation of mass or continuity equation first. Say to yourself, is it a one-dimensional problem or two-dimensional problem? Then put down the equation. In Banaras, it was always assumed that it's a one-dimensional problem. So that density, area, nothing is changing. You just write down things like that. So the approach was analyze it to the extent possible, and then, if necessary, you may have to go to more practical things for getting the answer to the problem. So the science base came in at that time. I could see it in MIT very much so. Though, as I said, I didn't take many. I took one or two of the courses, listened to them, bought the books, did the homework on my own in home, but got the gist of it. The other thing was professional skills were not taught that much at MIT. There were some things where you did a little turning, this, that, or a little carpentry. But it was expected that if you were going to be a mechanical engineer, you would have some interest, you would have handled some of these things as a child in your house, or you would have summer work somewhere and get interested in whatever you wanted. It wasn't that it was formally taught quite a lot. Nothing, there wasn't that much formal learning of drawing or workshop. And of course, the big difference was there's a lot of humanities and social sciences in the MIT undergraduate curriculum. They taught history, the history of Western civilization. There were good subjects in philosophy taught very well by renowned people in philosophy, sociology, etc. Taught very well. Economics, of course, was taught well, and so on. So that was the first time I saw an undergraduate program having so many courses. You had to take one course in each semester in the first 4 semesters, at least that. Okay, that's quite a bit. And that influenced me, obviously. As a graduate student, I went to do a master's. There was no compulsion to do these these HNSS courses, but I did buy a few of the books which they had and read from them just to get a gist of what was being taught. It was high-flown stuff. I mean, it's not trivial to come to know what was taught in them. They were expected to read things, write their own what you call essays on certain aspects and so on. So that was a big what I call takeaway for me. And obviously, when I came back to IIT, I knew that. Now, to some extent, IIT had already Bombay when I came already had some humanities and social sciences. It wasn't totally absent, unlike what I had done 10 years earlier at Banaras. There were 4 or 5 people in what was called a small department of humanities and social sciences. There was somebody teaching, ethics and logic, somebody teaching philosophy, somebody teaching English because that was necessary for some students, and a few other economics. These were, I think, the four subjects basically covered. They were taught well, by the way. Those instructors had to teach the whole class or half of at a time, and they used to do a good job. So I must say it was a good beginning, but it was probably not adequate. So that was one thing that was there already at IIT Bombay. And the science base, I thought, wasn't there in teaching more of physics or chemistry in the first year, second year. There was, but not to that extent. Less courses than I think came out later. So things were due for a change. And that change came, I think, mostly in Professor Kelkar's time in the 70s. When he came from IIT Kanpur. He'd been the director there for 9 or 10 years, and he wanted change, and it came. He said that, we want this changes, we want a credit system also to be introduced, a semester system, so on. So I was a member of the committees which were formed, two of them, and these changes were brought in during this period. And to this day, that emphasis on the basic sciences, something in humanities and social sciences, something in engineering sciences, and then applied engineering, which you can say, remains. The program at IIT Bombay remains in that structure, and almost all IITs follow this type of thing. The amounts vary depending on the IIT, all right? And in Bombay, for instance, the curriculum which I saw, say, few years ago, the basic and applied sciences, it is mostly basic sciences. Applied sciences are taught in the engineering courses. So the basic science is taught, that is more physics, more chemistry, was takes about, and biology also, takes about 20% at IIT Bombay now. The departmental core takes about 60% of the credits, and the humanities about 7-8%, and the professional skills is about 10-11%, where you learn computer programming utilization. I don't think there's any workshop course now. If at all, it's a very small part. I don't think they learn any drawing or by their own. If at all, they learn probably some computer aided drawing and things like that. So in that sense, what is taught under professional skills has changed naturally. It has to. But there is some professional skills being taught, amounting to probably about 10% of the curriculum. So the big changes came in the 70s, and to this day, the essential character remains that, accepting again that over the years, what we teach under engineering or what we teach even in the basic sciences has gradually been changing. That's the change that has taken place. So that's the kind of thing that has happened.
So it was great to hear about the differences in curriculum between BHU, MIT, and IIT Bombay in the initial years. Sir, your association with IIT Bombay started in 1965 when the institute was relatively new, and you have held leadership positions such as deputy director and director. How do you look back at this long association, and what have been the most satisfying experiences in this journey? Could you please summarize the key changes that you have seen in IIT Bombay over the decades with respect to the physical infrastructure, the students, and the institute's move towards becoming a comprehensive university?
You are right. I had a very long association with IIT Bombay. And by the way, it's not over. I'm an emeritus professor, as you know. So it's a lifetime association. But now the associate, I mean, in the sense of contributing, I'm doing very little. Here and there, some committees there on which they request me to come and things like that. So really things. I have very little of contribution to make now. But yes, when I was there, right, for the till 2000, the year 2000, that is those 35 years that I was associated directly, yes, there are many contributions. And now, and I held also the two administrative positions. Of course, prior to that, I was the head of the department from 1973 to 75. And then the deputy director for 2.5 years in the 80s, then again the director. I suppose it would be fair to say that it's been a very, what you call, and not an association which I have looked on as a burden. See, if you're always learning something in what you're doing, then that job gets done well. That's what I've always felt. If you feel that it's a burden, you'll at some time or the other just start doing things mechanically. And I've never looked on the job of being a director as a burden. I took it willingly towards the fag end when I knew I had 5 more years left to retire, that kind of thing, or almost just about 5 years left. But prior to that, I didn't want to get into administrative things because basically you can't teach much once you take up these jobs, or you can't do much research. Those who try to do it, they are supermen. Some of them do at other IITs and so on, but I call them Superman. Really, I found it impossible, and I gave it up. So as I said, I took up these jobs, and in fact, that was the reason why I gave up the deputy directorship. It was voluntary. I was appointed for a longer period, but I found very quickly that the job of deputy director took up too much of my time. And Professor Nag was the director. He joined in '84. I started with Professor Day. I was the deputy director for the last 6-8 months. He was the director. Then continued with Professor Nag. And Professor Nag was the director. And I still remember that after a year or so, I met him and I said, I don't want to continue as deputy director. And he said, why? What happened? What happened? As if, something serious had happened and I was resigning or some such thing. I said, nothing has happened. It's quite simple. I'm just not able to pay enough attention to my teaching and research. It's that simple. And right now, when I've just not crossed 50, I don't want to give up teaching and research. It's as simple as that, I said. And of course, you are free to fire me anytime. I said, if you say resign, I'll resign tomorrow. But if you want me to continue for some time till you find a successor, that's also fine. It's not that I need to go tomorrow. But please don't ask me to finish this term. It will be another long 6 months, 1 year. And I think, already I can see the signs that my teaching has deteriorated. Because while I'm teaching, I'm not concentrating on what I'm doing. That shouldn't happen. While I'm doing research, I'm not concentrating. That shouldn't happen. So he was quick to understand it. It was quite remarkable. Someone else could have said, no, impossible. It's another year or so you have to continue. Then I'll see. He was quick. We were good friends already within a short while. He was quick to understand what I said. And he said, I appreciate what you're saying. And I'll look around. Give me a little time. Give me about 6 months or so. And I'll definitely find somebody else who I feel can be willing and do the job. And then we'll make a change. So he did that, exactly. I mean, he kept his word. About a whole semester went by and he appointed, I think Professor Malik took over from me at that time and as deputy director, and everything was smooth after that. So you understand that the jobs do take up a lot of time. And if you do take them up, you need to really spend efforts on them. There are all kinds of problems which you have. So I went into administration willingly when I was about 55, and I knew that the retirement age was 60 at that time. It increased to 62 in my period, actually. So that was one thing I want to make clear, that I took these jobs when I thought I could do them, and also when I thought that I could now pass over to a new phase in my career. And in their own way, they were satisfying because you have some things in your mind which you want to do. You see, it's not that everything is going well. I mean, Professor Nag was the previous director. He was doing a very good job, in my view, as the director. Made many good changes. The whole computer science and engineering department really got going when he became the director. The whole big mainframe, in those days mainframes were still needed, was got because of his initiative when he took over as director in '84. So it did help that what he did. I mean, it did set us on new paths. Contacts with alumni were improved in his time, and so on. And to some extent, shall I say, uh, continued what he had started. He was very well aware of the things that he did. I think I'll just list two or three things which I thought were important, which I did, or which I got going at that time. One was, I was definitely of the view that we needed to strengthen our ties with alumni. And you see, the first batches that I taught were passed out in the 70s, 71 and all. Were already in 95. They were in many were in very responsible positions. They were wanting to interact in the institute. They were in different ways. And that was also a time when many of them were doing well financially also. IT had set, got into the blood, the Indian mainstream. So they wanted to help, but you need a setup to help. I mean, you need to have things. So I was convinced that we needed to strengthen our ties with alumni. That was one. And we did many things in that 5 year period. I mean, for instance, the IIT Bombay Heritage Fund was set up in the US so that donations could be directed through them and then to us. Of course, the setting up a fund meant that people giving donations there got some tax benefits and so on. And usually, if they gave something and worked in a company, the company they worked for would match that contribution. Things like that are there. So those benefits came. The IIT Bombay Alumni Association in India was strengthened. Chapters were opened in cities. The Bombay chapter really grew in size and what it did, what it wanted to do and did. And I thought it was a good period to do it. So we couldn't really get many things going that we wanted, but certain things did happen. Alumni Day was made a feature of the calendar. The last Sunday of December, I think, was made into an alumni day. So, like that, things were done, and that was a big day. Alumni came in large numbers. The director spent time with them. They had their own programs. The groups met later on and had their own evening dinners together. Uh, what the institute was doing, told them about what was doing. Well, in my time, we started honoring some of the alumni who had helped the institute. What we called the Distinguished Alumni Service Award was given. Service awards were given for the first time, and that's continued over the years. So such things were done, and even I visited the US twice in that period, specifically for spending time with alumni in the US, specifically. And at every place that I went, alumni took care of various things like where I met them. If I spoke for some time, took questions from them, whether it was Boston, Chicago, other cities like Pasadena in the south, in New Jersey, various places I went, Seattle, etc. I think it was a very good learning experience for me. Alumni's hospitality was so what you call it was great. That's the only way to describe it. And they were there to meet you at the airport. I stayed with some of them because they insisted that I stay with them rather than in a hotel. In fact, I think at every place that I went, I stayed with them, excepting I think in some places like Chicago where my younger brother was there. So obviously I stayed with him. Or in Boston where my other younger brother was, where I stayed with him. But otherwise, I went to San Francisco and then went to Pasadena. My son Gaurav was there then. So obviously, you don't stay in a hotel or with an alumni at that time. Like that. But the point is that the hospitality was such that you enjoyed that stay. It wasn't just about what you call money or what can you give us. That was never discussed by me. I learned this saying from the Vice Chancellor of University of California at Berkeley. He was a very good heat transfer man. And I met him because of his heat transfer, really. And he also the Vice Chancellor at Berkeley. The alumni had arranged that meeting with him. And when I met him, he said, you're going around meeting alumni. I said, yes. He said, remember, never talk to alumni about money. That's the last thing you should do. Others should approach them later. What you should talk about are what are the plans for the institute, the new academic plans, the new building plans, and so on. The bright future you see ahead for the institute. Talk about that. They want to hear that. Money part, it comes, he said, it comes. If you are genuine and they feel you're genuine, it will come. And I appreciated that comment. That's one of the few things which even today I remember as I speak to you. So those were short visits, 4 weeks or something, both times that I went in the summer. But I think they were productive in setting up links, and those links have remained. I mean, with alumni, and the institute also has broadened those links. There are more connections. There's a dean who looks after these affairs very carefully now, and so on. And of course, things are on a much bigger scale now. I mean, and we tried to speed up the way in which donations which were received at that time we could accept. Many of the administrative things I took care to remove. For instance, in the old days, even if somebody made a donation of 1 lakh of rupees, we needed board approval to take that 1 lakh. And the board meets about 4 times a year. So it was an agenda item which you needed to put on the board, and they would, of course, say yes. Then you could inform the alumnus that it's approved. Then he could pay his 1 lakh. I mean, 1 lakhs and 2 lakhs, even in those days, weren't big donations. So we changed that. I mean, I got the board itself was when I went to them saying we need to make these changes. They said, "What do you want? Just tell us." I mean, it's ridiculous that you should have to wait for such things. So we changed up many of those things, saying that up to a point the director takes the decision. Beyond a certain point, at the most, if it's a large donation, he gets the chairman's approval. And only cases which have some ifs and buts about them. That means some conditions are being laid, or you feel that we should be more careful in taking the donation. There you come to the board. That's the way it was basically discussed. I don't remember now how the minutes were written, but basically the small donations of a few lakhs were taken off the board. Either the director or the chairman of the board used to approve it, and the rest was, the other ones went to the board, and we benefited from that a lot. I could act immediately in some cases. Just go with a person, and somebody said, I want to give a donation of 3 lakhs for in memory of somebody. I'd say, yes, sure. Where's your checkbook? That kind of thing, and then talk over what do you want it named, and where do you want it given? Is it a scholarship or what, and things like that. So we did try to simplify things, and I think that was appreciated. Even for big donations, we moved rapidly in those days to see that they weren't kept hanging. And that I think in the long run, those moves have, if anything, made even simpler. Those rules were accepted. Of course, alumni visiting the campus increased then as a result. And it was one of my pleasures to always meet them and thank you. There's no question of saying I'm busy. Even if I was in something or the other, I would say that I will meet that alumnus if he wants to meet me, even for 5 minutes, that kind of thing. And it was genuine. It's not that I was doing it as a duty. I used to enjoy meeting them. Some cases they were mechanical engineering students, and some cases they were not. I hadn't even known them, but just knowing them, what they were doing, and so on, what plans they had in their companies, made a big difference to the way alumni started seeing the institute. And I think to a large extent we've kept that and kept that good, shall I say, link on. Now, the other way in which I think I'm going to just not talk about, uh, but saying that the the institute is a dynamic thing. I can't say that we made a curriculum in 1973 with Professor Kelkar, and it stays like that. There's no such thing. If the moment an institute says it was good enough then and it's good enough today, that institute should be closed down. Okay. Nothing should be, it was good enough then and we keep doing the same thing. People should not say such things. We expect change. Change is a part of any educational institute, whether it be the curriculum, whether it be the research work that you do, whether the way you handle alumni. I mean, everything has to keep changing. Change is the essence of an educational institution. We must welcome change. We must not say ever, as you grow older, the tendency grows to oppose suggestions from younger people. We must always be willing to listen to young people, young faculty, young students. They may be wrong, but you've got to listen through, see that idea, then maybe if you know really something's not going to work, you may say it. But if you think something will work, get somebody else associated with it, get it properly, what you call, investigated or seen whether it will work, and then go ahead and do what is being suggested. And that makes for a more open institute. It makes for an institute which I think in the long run develops good habits. Not that everything that you do should be also told to others. There are many things as a director or deputy director you have to keep to yourselves. I mean, there is no question about it. Exchanges with the ministry have to be kept confidential from time to time, and so on. There's no question. There are things you have to deal with as director which you would rather not talk about to everybody. But that apart, that is true all over the world. That apart, the institute, if it is to grow, must have an air of freshness. It must grow in all respects, whether it be, as I said, research or its teaching program. And to some extent, I tried to do that. Now, again, I'll give you some examples. I said that the BTech program was revised, but that continued. In my time, a big review was undertaken. I remember Professor Narayanan was the chairman of that committee, which undertook the review of the BTech programs as a whole in my time. And they came to the Senate. The essential features may have remained the same, like what I said a short while ago: basic science followed by engineering science, followed by engineering subjects, professional skills, HNSS. That remains the same. But within it, some introduction of some compulsory courses, putting some in electives which are compulsory, how many to put in mathematics and physics. This gets discussed and things get changed and modified as you go along. That has to happen. Sometimes at the institute level, and of course at the departmental level, it has to happen in terms of the electives which you introduce, or in terms of the departmental curriculum, which is basically the right of the department to change courses which are within their purview. So I think I encourage that, and even the starting of new programs was encouraged. For instance, I think we started a very good program in mathematics. I mean, this one comes to my mind. We have a very good mathematics department now, and it has grown over the years into being a very fine one. We had a MSc in mathematics, and there was an MSc, I think it was called Applied Mathematics, in which they taught, or one or two specializations were there in it. I've forgotten the details. So basically, they taught what I call was elasticity and fluid mechanics and not thermodynamics, but some heat transfer, taught by applied mathematicians. And that kind of mathematics has got outdated, really. And you need applied mathematics, or you need some other inputs into a program, but not that time. So the department's younger faculty wanted to make changes, and I think at that time we continued the MSc program in mathematics, but we introduced an MSc program in, I think the name was Applied Statistics and Informatics. And I think it's still running as far as I know. It's a very good program. It takes people who've done bachelor's degrees in mathematics and done well, and are interested in applied subjects, because these are the people who go into IT and computer science later from the science side. So that was a good program. It's still running. In my time, I mean, we made a very positive movement to start the School of Management. That had been decided in Professor Nath's time, and the School of Management had been approved by the Senate and the board, that we would have a School of Management more on the lines of managing technologies, technology management, and so on. But nothing had been done. I mean, we were going through, financially, the institute was in poor shape in the late 91, 92, and so on. And the budget from the ministry had been cut for all, not just for us. So we wanted to implement that, and we decided to implement it when I became director. Partly because I think two sponsors had come forward to give forward money which would at least help us to get the building started as a School of Management. And we decided to start it. First in a temporary, a few classrooms I think in the maths department and the computer science department, borrowed 2 rooms essentially to start it off. appointed one or two people who were core faculty, and then others who were already teaching subjects like industrial management, economics, etc., which were part of the curriculum. Another, so that we could get going by July of that year. And the first program was started, the Master of Management, and it has also done well. It has done well. I think that it could do better. That's what I say about everything in the institute. You can always do better. So that's done well. That was started in my time. And I think another major step which took, I think, is also important was the institute had recognized the importance of biotechnology and biosciences by then. But the beginning had been made only with a few MTech programs which were not really linked with each other. For instance, there was an MSc program in biotechnology which took about 10 or 12 students every year. Some faculty had been recruited for them. There was an MTech program in biomedical engineering which had been started in Professor Day's time. And it was also doing reasonably well. They used to admit doctors, MBBS, as well as engineers. And then those who were doctors were given some training in the first semester MTech program, some courses in electronics, etc. And the others who were physics people were given the training in the reverse, little of elementary biology, something like that. And then they did a course in biomedical engineering. So it was the first semester they caught up with their background and then went on to do biomedical. And so both doctors and MSc students took that course. So also doing well, 6 or 8 students a year or 12 students a year. But then a time had come not to treat biology as something to be taught, but to give it a better status. And that was a beginning made in my time through the Senate. I appointed a committee which was consisted of outsiders and someone from the institute. And I said, look into this. It's time we started a group or maybe a department of biology. I think one other IIT had already started such a department. I'm not sure. I think Delhi had already. And I said, we need to give a department of biosciences, biotechnology, bioengineering, whatever you think needs to be called. But we need people who do basic stuff in bio. Again, what they do, I don't want to say whether they go to the molecular side or the cellular side or the macro side. I don't want to say that. But certainly we need to have a good department of biology. And within that, we should have these MTech program, which may continue if you feel if the faculty feel it's worth continuing, or we should have this biotechnology program. It was already attracting good students. I said, there's no reason why it cannot be part of this new. But I wanted the group, which was an expert group, to really look at whether we shouldn't be thinking of growing activities in biosciences and bioengineering, so that unless you have that base, you're only doing the applications. That shouldn't happen. You follow? When you're doing two MTech programs, that's all that you're doing. Then the faculty, which might have a basic interest, start losing that interest in their research also. So we got a committee, and its report was also came just about the time I left, or so discussed by the Senate, approved, and now I can say, 20 years later, at some stage we got a full-fledged department. I think we have about 30 faculty members in the department. They're doing well. They've got lots of sponsored projects. They're doing good work. And of course, these two, I think both these programs are still continuing. The biotechnology, MSc, as well as the. So good things are happening. Good things are initiated. Good things are happening. If you refer to after I left, I think an important thing that has happened in the last few years, I don't know the year again, is we've started a BS program in economics. Now, I don't know if everyone is familiar with the BS program. A BSc program, as we understand it in the universities, is a 3-year program after the 12th. And the MSc follows it as a 2-year program. Now, the BS program, which is now being run in India, it's being run, for instance, at the Indian Institute of Science, is a 4-year program which is done after JEE. You can have your admission after JEE, that is after the 12th, and do a 4-year program in which you get a BS, Bachelor of Science, BS, not BSc. And this has a little more time in it. It's not just 3 years. So you get some grounding in the sciences, then a good grounding in what you want to specialize it, physics or chemistry or biology or whatever it is. And then you have the time to do a thesis, like in a BTech thesis, some kind of thesis, at least I think it's 6 months or maybe 2 semesters. Again, I'm not sure of the years. So the BS program is in economics is, I think, a good program. It's already attracting good students through JEE, that's what I was told. And I think it needs to grow. The economics faculty also has grown over the years. If I tell you that there was only one teacher of economics in 1965 when I joined, and today I think there are 7 or 8 or 10, and the Department of Humanities, but they are part of the Department of Humanities and Social Sciences, and I think probably the department has more than 30 or maybe 35 faculty members now. So it's a good department, and this beginning of starting a BS program in economics is, I think, is a good beginning that we've made. So things are happening as they should, and I don't want to talk about physical infrastructure. You ask me physical infrastructure. Well, with the times, as more programs come, more buildings are needed, more faculty are needed, more hostels are needed, and everything is now going up vertically. That's the big change on the campus. In my time when I joined, there was no building more than 1+2, the ground plus two. Okay? All the quarters, all the hostels, everything, if at all had more than a ground floor, it went up 2 floors. Today, there's no such thing as making a building like that. Everything is at least 7 or 8 floors or 14 or something like that with elevators and so on. So that change is very much part of the institute. Whether it's residential for students, whether it's residences for faculty, whether it's centers or departments being built within the academic area. Everything is going up. So that's the big change. And I think it's necessary given that space is not unlimited. But some things remain, and they should. The infinity corridor remains very much an infinite corridor. It had to be repaired quite a lot because it had gradually become a little decrepit. So the whole thing really had to be brought down and built again, and it's been done quite nicely. And so it's very much there. It's very much a part of the IIT Bombay culture now to say that that's our infinite corridor. And other buildings, of course, the main building remains the same, but interspersed all over, there are taller buildings, and that's the way it should be. There are many centers also, by the way, which you should be aware of, which are broadening our horizon. For instance, I think I'll just name 2 or 3. There's a Center for Urban Science and Technology. There's a Center for what you call policy research in policies. There are various other centers which are concerned with climate change and so on. At least 10 centers. There are some centers specifically for having contact with industry so that we get projects directly. That's called the Tata Center, I know. Things like that. So at least centers. So centers are improving not only our contact with the outside world, they're widening the horizon of what we teach. As I said, some of these centers have education programs, certainly have a PhD program, some of them. And in that sense, we are gradually going towards what you referred to, I think, as a comprehensive university. I think that was the word you used. A comprehensive university means one in which the name remains IIT, but there are some other things which are could be very much a part of a university or an IIT, and broaden the vision not only of students who come within it, but also of the faculty within it. I must tell you historically that the first such move was made in 1969 when the Industrial Design Center was started. The Industrial Design Center was very much something going out of the way for IIT. And many of the faculty members at that time said, this is not engineering. Industrial design means you admit some engineers, some architects, some fine arts people, and they learn how to design products which we have designed so that they look better. That was a phrase used. And very soon, it became apparent that industrial design is more than just making things look better. The whole science of ergonomics, for instance, comes in that. And just to give you an example. So industrial design, has the center has grown. It has a big, it has a, I know a group on visual communication, which also started some time back. Maybe there are other groups now, I don't know the recent things. But I was very familiar with the IDC because it was next to the mechanical engineering department, as you know. And the these centers, in a sense, was the beginning of what I call a contact with the outside world, if you ask me. Outside world means the world of arts, not just the world of technology and engineering. So we made that beginning, and it has grown now. And we've, of course, got much stronger science departments now than we had. They were strong then, but they've grown even more. They are known nationwide now. Our Department of Chemistry, or the Department of Biology, or Physics are known, or Mathematics are known for the faculty that they have. We even have an advanced center for mathematics, which attracts some very, very distinguished people every year to spend time with us here. So the institute has moved. The faculty have grown in size. Faculty are more dispersed. Half the faculty, three-quarters of the faculty don't know most of the new faculty. And that happens in any institute as it grows in size. Everybody seems more busy than they were in our time. We had time to walk around, take evening walks. I don't know how many do that in the campus. Some do, but I think too many people are running around too much, except in right now for these 3 months when a lockdown is forced on you. But there's a different air about having younger faculty. They see things differently. They do things differently. They're far more savvy with, of course, computers and software, and it should be that. We should never say, "In my time, we did this," and so try to stop. We should encourage all change. If they don't want to do it, if they don't think it's good, or they find out it's not good, they'll themselves correct the situation on their own. That's the way I see it. We take intelligent people after all as faculty. You get very intelligent people as students. There's no reason why they shouldn't take intelligent decisions, even if occasionally they take decisions which seem a little, shall I say, not quite what you want to see happen. That's the way one should take things. Let things grow. And the institute has grown. All the signs are that we are a top grade institute in India, no question about it. Our goal shouldn't be to stop there, obviously. We shouldn't be thinking of being the best in India. We should be thinking of much more in whatever we do. And that is why during my tenureship, I gave in one of the convocations, the director gives his address. And at the end of that address, I very spontaneously, it's not there in the text, if you see that address even in the library, you won't see that sentence. I said that it was in 97, I think, or 96, I've forgotten. I said, this institute has a tryst with excellence, and we shall keep it. When I give such a signal, when I make such a statement, I don't make it for fun. I think we can do it. We must keep that tryst with excellence. If we keep it, we'll move up the ladder. People will admire us for what we do. They admire us already, no question about it. They'll admire us even more. And who doesn't like to be admired? Institutes certainly do. So let's keep that tryst with excellence. And as alumni or whoever you are listening to this, if you ever find something that you can do for IIT Bombay, in whichever way, not whichever way you can help, do that. The institute needs suggestions so that it keeps that tryst with excellence. I want to tell you one more thing about MIT. The contact with it keeps with its alumni is amazing. Today, it's 50 years since I passed out of MIT with a doctorate. 55 years, sorry. Okay, 56 years. Okay, and yet today, every other day on my computer, or not so much by post, no, more on the computer, I get a message or something from the department or from the institute telling about some new activity at the institute, some new things they have done. Also telling us as alumni about problems they are facing. presently what's going on there, how they are tackling the COVID-19 crisis also. I keep getting detailed accounts of that. So it's always nice to feel that your institute cares for you, that they ask you, and they say you're open to write. I mean, of course, as you grow older, you absorb it, you read it a little, but I think that contact has to be maintained. It costs so little, and yet it gives you a wonderful feedback on what you do.
Sir, your account about your experiences as director was very, very inspiring. And as an IIT Bombay alumnus myself, it was very educative for me to learn about the recent developments in the evolution of the institute. So it is really wonderful to hear about all these things, sir. Sir, you have received many prestigious awards and honors, such as Padma Shri, the Bhatnagar Award, the IIT Bombay Lifetime Achievement Award. Which of these gave you the most amount of satisfaction?
Well, that's a difficult question again. Uh, the Padma Shri is the one people know about most, and but to be quite honest, the award that really excited me the most was the Bhatnagar Prize in Science and Technology, which I received in 1984, which was awarded to me in 1984. The actual ceremony took place in 1986. The function was not held for 3 years for certain reasons. Mrs. Gandhi passed away and so on. It's a function at which the Prime Minister traditionally comes and gives the award. The Bhatnagar Award is in memory of Professor Shanti Swarup Bhatnagar, who was one of India's pioneers in setting up institutes, colleges, etc. And uh, in fact, I think, if I remember correctly, he was a member of that committee which suggested that IITs be started. Okay, he was a member of that committee. That's my recollection. Now, the Bhatnagar Award is given in areas mathematics, physics, chemistry, uh, engineering science, biology, and two or three others, like that, earth sciences, and so on. Seven or eight, I don't know remember the exact number. But it's an award given across the country and given usually to one person. Sometimes it's shared, that is, two people are given. And it does give you a status immediately, that when you're given that award, you're being recognized not just within IIT but across the nation. That IIT Bombay so and so got this award, and I was quite proud when I got it. And that was, as I said, in the 80s, 84, I think. And it was primarily given for the work I had done in both in heat transfer and in solar energy. Uh, Partly perhaps for the book I had written, which was also well known by then. Both the books had come out by that time, but more, it was not so much for teaching, it was more for research. And in both of those, they were really recognizing that I had done good work, and which was recognized, which had got published in very good journals, and also, in a sense, pioneering work, because there's also an application orientation in it, and which gave a boost to solar energy research in the country. So I was very proud of that, and in fact, it was a great moment to receive the award finally in 1986 in person from Mr. Rajiv Gandhi, the then Prime Minister. So it was a great honor to receive it. And I also do value very much that I was awarded the Padma Shri, but the Bhatnagar Award was the first one. You see. The other ones came later, and in a sense, it excited me a lot more. That's why I said that's the one I treasure. And as I sit just now, right in front of me on the wall, other wall, which you can't see, is a plaque which was given to us later, not right there, but in which it says SS Bhatnagar Prize. My name is on it in engineering science. It says on that which was awarded to us later at a function to many awardees of different years later. So that I think was the big thing for me.
Sir, we are now in the age of the fourth industrial revolution, where new possibilities due to artificial intelligence, machine learning, and online teaching and learning are being constantly being talked about. How would these developments impact the universities of tomorrow?
Well, the main thing that I can talk about is how would they affect the courses that are taught, that is the curriculum, and how will they affect the way they are taught, the methodology of teaching. This is how new technology is going to affect us. Online, I mean, how the teaching is done and what you teach, the content of what you teach. So there's nothing better than to go to our BTech curriculum. I mentioned to you the changes that have taken place over the years, and I can already see changes in our curriculum. For instance, if you look at a computer science and engineering curriculum today, in any good university like ours, you will see there are courses on artificial intelligence, there are courses on machine learning, and of course more parts of them which are different names are also being taught. And in detail, the theory of them is being taught. A computer science student shouldn't be learning how to use just the software which goes with these now, which are available, but what's the science which goes behind making. So already our curricula are getting affected and will get affected more. Similarly, even in engineering departments, where science bases are there, a course, at least a course on how we get to artificial intelligence techniques and what the software is based on has to be taught. You can't just say this is software and use it. You can give that only to people who are in the field, saying this is a software written in artificial intelligence. Get this data, put it in, and it will give you this answer. That's okay. You need hundreds of people for doing that. But at least you need engineers who understand what that software does. So they need to know the limitations of software. They need to know how the software originates. And for that, you need to know a little artificial intelligence. And you need to know a little of machine learning. And I think you're going to see compulsory courses in this, at least courses in this, for many engineering students in good universities like mechanical engineering, electrical engineering, almost certainly, and even in other ones like civil or whatever other main branches that we have in metallurgy. We'll need this because even if it comes to interpreting something like data, the hours we used to spend in interpreting data and trying to get some sense out of data in the old days, when there were 3 or 4 parameters involved, trying to correlate that data. And now what is done just in a jiffy by basically software which uses artificial intelligence, zeroes in quickly on the types of correlations that will work, and then does the correlating for you. Sometimes even in real time it can be done. Now this is the kind of thing we are going to need. So you need engineers who understand this. Otherwise, they'll buy the wrong types of software, which must be costly initially at least. So we need these changes in curricula which are going to come. That is one side, changes in curricula, which means to some extent, perhaps manufacturing science will need changes also. Obviously, if you have a robot which is going to manufacture your products for you, you can't just say it's a robot. You need to teach something more in robotics, right? Which means again that some artificial intelligence has gone into that robotics if that robot has to work in a complicated fashion. So I can see these changes coming into curricula quite rapidly, and they are needed. There's no question about it. The other change is going to come in teaching methods. Uh, you see, whether we like it or not, we will have to rely more on computers and software for doing our teaching. Already, because of this COVID-19 thing, people are saying online teaching should be done. And people who say this don't recognize the difficulty of doing online teaching properly. All that they do is they say this school, the class will be for 7 hours. So for 7 hours, you'll sit at home in front of your laptop. And for 7 hours, one after another, they will show a recorded lecture by a person. Now, do you expect a student who's, 12, 13, 14 years old to sit for 7 hours? Maybe they give breaks in between, you know. But do you expect them to sit for 7 hours or 6 hours just hearing a lecture with no interruptions, no questions being asked either to the students or by the students to the teachers? Nothing. So the whole thing it will be carried on because of this emergency, but it's not going to be so effective. The point I'm trying to make is online learning, whether it be because it is needed because of the COVID pandemic, or whether it's being done through a MOOC, massive online courses which are there. Online this thing requires that you have some teacher interaction in the form of recitations, tutorials, in the form of test quizzes, in the form of some contact with the teacher, open-ended contact. That's needed. And if you say that we'll manage without it, as is done in some online, really the course gets diluted. The amount you teach or the way you teach it or what gets across to students gets reduced. There's no question about it. So you might say I'm trying to see that the teacher's race doesn't disappear. Well, you can say that if you like. But the fact is, you do need teachers. But you need teachers who adapt to these changes. A teacher cannot say, that I know nothing about artificial intelligence. If you want, go there and learn something about it. Teacher has to, even if he or she is not in that area, should know at least what artificial intelligence does and be able to at least understand what are its implications. That's important. Or what machine learning does. That's important. When an automatic translation is done of something that you write, well, what is going on inside that software? Are there thousands of words and is one word picked out of it because it looks similar or what? How does the software work? I don't know some of the answers, but I'd be curious to know if something is automatically translated. Well, what is it that's inside that software? What kind of recognition methods are there that work and work with, shall I say, in an optimum fashion? So we need that. So teaching is going to change, teaching methods are going to change. And the other major point I make is teachers are going to be needed, but teachers with a different outlook. And as I said, that will come with time and will come as if you pick good, bright young people. That's what IITs do all the time. They pick bright young people and give them the independence to develop their courses. They pick bright young students also through JV, and they give them a lot of independence, mostly used well, some cases not used well. But in the end, most of them do well when they go outside. And that's what we look for. A place like that. Let such IITs grow.
Sir, I've spoken to many mechanical engineering alumni from IIT Bombay before this discussion, and they remember you a lot for your lectures and also for the values that you taught them, such as being a good citizen and about the importance of perfectionism. They also remember you as being always extremely well dressed, and they also remember you for being kind and not being vindictive when students did something wrong. Some students have shared that you were firm, gentle, and kind, and not even remotely vindictive when you corrected them for their mistakes. For instance, one student ended up being on your wrong side twice in the same semester. And there was another instance where two students were actually littering by throwing a coffee cup in the wrong place, and you corrected them. And they have told me that they've never done anything like that again in their lives. These soft skills that you taught them were very important life lessons and are as important as the technical subjects. And one person has shared with me that a talk that you gave in his fourth year on how to make a good presentation was the best talk that he has ever heard in his life. And sir, another statement that is remembered by many of your students is that as good engineers, one should be able to make reasonable assumptions when there is not enough data. Your students are extremely grateful, sir, for the kind of impact that you have made on them, both at a technical level and also at a soft skill level, which I just mentioned earlier. And one of your students, sir, of the Mechanical Engineering 92 class has written a poem in order to express his gratitude to you. And this poem has been written by him on behalf of the entire Mechanical Engineering class of 1992, which I shall read out now to you, sir.
Yeah.
We salute you, O sir. As a teacher, no one was better than you. We tried hard to stay away, but heat transfer and renewable energy managed to find a way into our minds thanks to you. Of other subjects in the department, honestly, we had little clue. Oh, sir, we salute you. To us, more than a professor, you were an educator, teaching us lessons of life, the importance of focus and resilience over petty vengeance. Oh, sir, we salute you. For us, you were an example of not just the cerebral, but also the sartorial. In your own way, subtle, you taught us to be responsible. Oh, sir, we salute you.
Yeah.
Sir, I hope you liked the poem.
Yeah. Very good, very good. It's moving. I liked it. It's a great, very fine expression of what the person feels. And let me tell you that it's always a pleasure to hear from alumni and to meet them. And it happens all over the place. You're sitting for, say, at the airport to catch your flight, and somebody suddenly stops and says, "Sir, do you remember me?" And you say, "Look, I don't." Do you know he's an IIT Bombay alumnus? And then he or she will introduce herself and chat for some time. Like that, that happens all the time, whether you're going by in a public place somewhere here or there. It's very nice. It's a good feeling. You feel that you've achieved something which is appreciated. And I'm glad he used the word educator because I meant to say that myself. A university or like an IIT is not meant just to do teaching. It's you come there to be taught, you come there to be educated, particularly because it's a residential university. You come there to be educated. Education is what we are giving. And so once in a while, I would say to somebody, if I right in front of me, somebody threw something. But I think in my whole 40 years, maybe half a dozen times I may have done that. That's about it. That said to somebody, please don't throw there. This is not the place. Or, something else like making too much noise outside a classroom when I was lecturing and just come out and say, please, somewhere else, things like that. Or uh, even copying. I mean, there are ways of putting across your message. You come to know somebody is copied in a test. You don't try to what you call shame the person in public. You meet the person afterwards, or the two of them copying. If you know who has given and who has given the material and who has copied it, meet both of them and say, look, this is not done. And they do appreciate it. And there's no question about it that they appreciate what you say and probably would set higher standards for themselves as they go along. So an institute like ours is about giving an education. It's not just about teaching. Teaching is the bare part, what you're teaching in a course, the equations and that part. You're also trying to make them aware of the world around them when you uh, do this. For instance, many IIT students I found over the years or do not know how much the nation spends on them. You see, I mean, typically, even 30 years ago, on each student, every year who was studying, every undergraduate student, the institute, that is the government of India, was spending about 1.5 to 2 lakhs a year. All right. The tuition fee was actually 1,000 rupees till some 84. It was raised to something. Then in my time, it was raised to 15,000. Now it is even more. But the point is that the tuition fee was not even a small fraction of the amount being spent by the IIT, and that is the nation, on each student. And so one day I still remember that an alumnus came up to me much later in Pune. I met him in Pune, and he said, I remember you for that. You pointed out to us that somebody was speaking in the class and it was disturbing. So you said to him, please don't. And then you went on to give this, to say that the institute spends so much for you. The least you can do is at least hear what I have to say quietly without disturbing me and all the others. So he said, I remember you were saying that to a student who was doing that. And it made a deep impression on me because you went on to point out That 1 or 2 lakhs that the institute was spending on each student, with that 1 or 2 lakhs, you could run 1 or 2 primary schools in a village. That's what it used to cost to run a primary village. A small room in which students, 30 of them, usually 2 classes at the most, sit on a carpet. There's one table in front and one blackboard, one teacher to handle, somewhere in a small village. That's what it costs. And I said, the least you can do is to at least stay a little composed and quiet and listen to what I have to say. Is that too much to ask? And of course, the class was quiet after that. But the point is, nearly maybe 15 years later, the student met me and he said, I remember that. So it's not that you say this all the time and keep every other day you're pulling up somebody. If you do that, what you say will have less effect. You'll also think you'll lose the what you call the what you call the feeling that you have when you say. It doesn't come out because you have to say it. It comes out because you are feeling that this is wrong. I must point it out to the other person. And as I said, I do it very rarely. I did it very rarely. Now, of course, you don't pull up anybody. Others pull you up because you're sleeping too much or talking too much.
Sir, a lot of IIT Bombay alumni who were on campus in the late 80s and early 90s would know your sons, Gaurav and Jai.
Yeah.
Could you please briefly speak about them and tell our viewers about what they are into today?
Well, Gaurav is my older son. He is 50 years old now. Passed in 1991 in computer science and engineering, BTech in computer science and engineering. And Jai is my younger son. He's 47, or will be 47 shortly. And he's he did his BTech in engineering physics from 91 to 95. So Gaurav left and Jai joined. That's really what happened. Of course, we have another connection with IIT, and that is my daughter-in-law, Gaurav's wife, Kalyani, is Professor Limay of mathematics daughter. And so we have a third connection now also with the IIT, close one, of BTechs. So coming back to Gaurav and Jai, Gaurav went on to do a PhD in robotics at the University of Southern California. And he's been with the University of Southern California right through, more or less with them right through. He was a postdoctoral fellow, he was an assistant professor, he became a professor quite a long time ago, and he was the chairman of the department, and now he's in fact the associate dean of the School of Engineering at the University of Southern California. So he's a busy person in his work. The most outstanding thing, of course, he has done is his research in robotics, widely known for it, widely cited, very widely cited, I should say, for the work he's done. So if you do look up citations against Sukhatme, the first name you will probably see is Gaurav's in it. I mean, many Sukhatmes are there, who are my cousins and younger brothers, so on, but his is the name you will see in terms of citations. Then, so he's done well and he's doing well, and we are in touch all the time, of course. They come to India occasionally, we go there occasionally, my wife and I. And my younger son, Jai, did his master's at the University of California in Davis. Then he went to the University of Chicago and did his PhD there in the area of atmospheric sciences. He was interested in that field earlier, and he did a PhD there in Chicago, which is a very good place to do a PhD. And after that, he worked for a few years at the National Center for Atmospheric Sciences in Boulder, Colorado. Then he was a few years at Wisconsin also, where he was also a postdoctoral fellow. It's quite mathematical what he does. The work about, I don't understand it, though it's atmospheric sciences and fluid mechanics. I don't understand one bit of it when he explains to me. I mean, the details of what he's saying. But it has implications for large scale issues which take place weather wise or climate wise. And he has PhD students. He's at the Indian Institute of Science, the Center for Atmospheric and Ocean Sciences. Faculty member there, he's a prof there. He's an associate prof there, doing very well. He's been there about 7, 8 years now, doing very well and enjoys it. He likes really research with PhD students. He has a whole host of them with him. He doesn't like teaching as much, since we are talking about teaching and research. I once asked him, why didn't you try for an IIT? Or, I mean, when he was thinking of coming back, like me, he spent about 6 years after his doctorate, but he was definite that he wanted to come back. So he said, no, I really don't think I enjoy teaching. So he was very clear he wanted to go to a place where there's research primarily. At the Institute of Science, he has to do teaching, of course, but it's postgraduate teaching, the MTech class that he teaches, or the MSc class that they have to teach. There are 15 or 20 students, and usually it's one course a year. That means, in one semester, a full course, or half a course, that kind of thing. They have basically, the time is given to the faculty to do research with their students. That is really the purpose. But the Institute of Science has really a lot of time for research, and their faculty do a lot more research. No question about it. So they're both very happy, and naturally, I am happy because they're both professors. What is no satisfaction better than that? Splendid atmosphere. They grew up on the campus, love the campus still very much because they spent so many years there, and look forward whenever they visit here just for a quick whirl around the campus. So that's the way life is. And, I think it's been great to talk about them to you. What I've tried to do here in brief today is really what you call tried to give a picture of my life within IIT and how it's been. I haven't gone, as I said, into the other areas. Many connect, as I said, long association with atomic energy and so on. I've sort of avoided that, not because there's anything confidential as people think, but because that would be another story or something different altogether. Or I avoided talking too much about my Banaras days. I was 4 years in a hostel there, talking about my school in New Delhi where I grew up, went to St. Columba School. I thought that there's far too much to say. What I really said is, I've talked about my experiences. That was one thing, teaching, research, and so on. I've talked about how the institute has grown over the years and what the things I favor, the areas of work, etc. I have talked about some of the things I did as director to some extent to get an idea of what was going on. And of course, at the end, it was very nice that students pointed out that they've learned certain values because ultimately it's education. It's not just teaching that we are doing. Any place, any college must be for giving a certain broad based education, learning your place in society, what you want to do, what you should do, and certainly day to day behavior is part of that education. So, as I said, it is not something which I was imparting all the time, that kind of education. But it comes naturally to you if you are teaching students and you feel like really telling them something which is which will do them good in the long run. So, it's been great uh, talking to you, giving you information, giving my views on so many things. Uh, and it's been a great it's been a great thing to be associated with this IIT.
Sir, it has been really wonderful to have this discussion with you today, sir. And this discussion has been very inspiring as well as very educative because, frankly, as an alumnus who graduated in 92, I had no idea about the recent history of the evolution of the institute. So I had heard about it here and there, about management and all that. But when you actually explained it, there was a lot of very interesting information that I got to know. That was
Great.
really wonderful, sir. For me from many different perspectives. I have learned a lot about the institute as part of this discussion. And as an IIT Bombay alumnus, I am extremely grateful to you, sir, for your very deep and extremely significant contributions since 1965 for making the institute what it is today, sir. Today, when I actually see that IIT Bombay has become the most sought after institute for the candidates who are getting past the IIT JEE. This gives me a tremendous joy as an IIT Bombay alumnus. I'm very grateful to you for having played an important role in making that happen, sir. Thank you very much.
Thank you. Thank you, Vivek. Thank you very much.
So thanks a lot for this discussion, sir. Thank you very much, sir.